Okay, so here I just want to tackle a small problem with that is a mathematical problem which is has been posed. You can find this one on other videos on YouTube, where mathematicians and physicists are trying to prove that if you add these numbers from 1 to infinity, you get an astounding number which is equal to -1/12, which is interesting. Because now what you have here, you have all the numbers which are continuously increasing up to infinity with as much as what we understand from infinity, you get this -1/12. Now the way to prove this one, the way that at least one of the proofs that leads to this result, it has been approached through a few steps, which I'm just going to show them here. And then I'll just offer one perspective of why this problem could appear to give this result, while this is most probably, it's counterintuitive. And yeah, I'll just offer one perspective. There may be other people who have other ideas or other approaches or explanations about this story, but the way that this problem is approached, one of the ways is the following, where they try first to define this a variable which is equal to s1, and they say that this one is equal to 1, -1, +1, -1, +1. So it goes like this, and what they say is that as the number of ones that we see here, with a plus or with a minus between them, if the numbers of those numbers whose absolute value is 1 is an even number, you are going to get a 0 for s1. So s1, it can actually be 0, but if it is odd, it's going to be just 1. Well, the first step they say that well, as you go to infinity, it's going to be the 0 and 1, but they say, well, it's equal to 1/2. So that's the first step that they offer, okay? Actually, which we believe is one of the major reasons why we may be misled to this result from the mathematical point of view, not from the physical point of view. So physicists may be happy with it, they use it a lot, physicists and chemists, they use it a lot. We have been telling this story to students in schools, etc., of how certain structures can be equal to 1/2. Now the thing is that after they prove this one, they go into the next step and they say that they have a new variable which is called s2, and this s2, they define it as follows: 1, -2, +3, -4, +5, -6, and so on. So, and this one may very well be defined as something like this, where we have -1 to the power n -1 times n, where n goes from 1 to very large values, let's say, for the moment. So they start first, they define this s1, then they define this s2, and then also accepting that s1 was equal to 1/2, what they do this one. They say that 2s2 is equal to 1 -2 +3 -4 +5 -6. When they add the s2, they just shift them to the side. Right now, I'm just repeating what the others have been doing, so I'm not telling anything new for the moment. And then here we have another +5 and so on. And once they add this up, yeah, this one comes up something like 1 -1 from here, 3 -2, we get +1, and this is -1 +1 -1 again. And then they say that, you know what, they say that this 2s2 is equal to, the summation, as it was shown here for s1, is equal to 1/2. So here, they reuse a result which from the perspective of physicists it's okay, but from the perspective of a mathematician may not be okay. And the thing is that with this assumption, and then coming here to the second point, they say that, you know what, 2s2 is equal to 1/2, then they say that s2 itself is equal to 1/4. And then they use this result to go and to find another quantity which is s minus s2, and this is equal to something, etc. And once they do the results and the results, they end up into this one saying that this s that we are trying to find is equal to minus 1 over 12. Now, the thing is that first I may just not cut short, I may say one of the essence of what I want to say here is that physicists have been telling stories like this a lot, and one of the well-accepted stories around is the model of hydrogen atom, where hydrogen atom has has a nucleus, a proton, and it has somewhere at a certain distance an electron, which is and we show it like this. Okay, we say that this is the hydrogen atom, and then we say that with all our accepted models of nuclear structure, we say that this electron is at a distance r. We very well draw this as a sphere, and everybody may have the perception that this electron is moving in a sphere around the nucleus. And the thing is that, interestingly, this r, we assign this one as 1 over 2. And, well, it's 1 over 2, it has a unit, because it's a distance, is angstrom, which very well is which can be written 1 over 2 times 10 to the power minus 10 meter. That's what it is. Now, accepting this one, okay, we consider this one also as the size of the hydrogen atom, but here we have a problem. The problem is that in hydrogen atom, the lowest energy state for electron, we call this an s-electron. And then we have this other stage, which many students from high school may remember, this electron structure, where we say that the energy is defined by n, which n goes like 1, then n goes to 2, etc. Then there is another quantum number, which is the L, and this L, actually, this L can have values like 0, it can have values of 1, L is equal to 2, and what this L stands for, this is actually the angular momentum of an electron, and when L is equal to 0, this is the S electron. When L is equal to 1, this is the P electron, D, so, and it goes on with F and so on. Now the thing is that if this electron in the hydrogen atom, in its lowest energy state, it has an L equal to 0, this implies that the angular momentum of that electron is equal to 0, which does not match very well with this electron, which we may be fooled as if this is moving in a circular radius like this, because we always see that the electron an hydrogen atom with a single electron, that's the structure, we draw a circle. But in case we have such a structure, if we accept that, then we should say that the angular momentum should be something which is equal to r cross p, where this cross product, the r cross mass times velocity of the electron. And then this most probably looks to something which is different from 0, but we assign this one as an electron of the s state, which is equal to 0, so here we have a problem. But the thing is that, yeah, the physics and chemistry community has made this accepted. Yeah, the models, they very well agree that this angular momentum should be 0 because it's an s electron. Oh, that's okay. But the problem is that, in fact, the reality, this radius is not showing where the electron is. Electron is not at this 1 over 2 angstrom, 1 over 2 times 10 to the power minus 10. This is the probability where most probably this electron is going to be found at. So if we draw the probability where the electron is going to be found, we can draw this one. So right at the radius 0.5 angstrom, here the probability is the highest, and the probability drops as you get closer or further. So this is the probability where to find that electron, and rather than a circular path, and also the probability to find it here, it's something like this. The probability increases here, and then it decreases again, so most probably the electron is here. So you can draw this probability, you can draw the probability of where the electron can be found all around this circle, and then we may draw something like this. But in reality, what the electron may be doing, it may be doing just crosses like this. It comes to a certain point, it comes back here again and again and again. Okay, so that's what in reality it better is, which implies that, well, the angular momentum, for sure the path is not that one, but then we come across this problem that even if it does a motion like this, the angular momentum, again, it will not be zero, because any object which is not hitting a certain point, its angular momentum is never going to be equal to zero. So still the problem is not solved. But as much as physics and chemistry is heavy with, is that we're accepting that this electron is located at a value of 1/2. But again, this is not the real distance, but it's the probability where the electron is most of the time, let's say so. Or the highest probability to find that electron is at this radius, 1/2 angstrom. So yeah, for physicists, it's good for physicists to say that you could have a 50% probability of getting a result of 0 and a 50% probability of getting a number of 1 for this S1, where all the problem may seem to have started. And with this in mind, physicists would be very happy saying, well, we have a system with two different probabilities, 50-50, that's fair enough. Or let's not say 50-50 in physics, they are not always 50-50. Yeah, actually, yeah, they are. But the thing is that in overall, we could say that it would be 1/2. It's true for physics, but it may not be okay for mathematicians. So mathematicians maybe they have to find some other reasoning when they try to tend to say that this summation of numbers from 1 to infinity is going to be minus 1/12. Yes, this may be one of the starting points of the discussion, or maybe this may be one of the tricky points. I may just erase this part where the ideas are explained here, or I can also say the following. I can say that we can analyze this problem for two different cases, where n, or the last number in the series, when we find this s, we can analyze this one for two different situations. One, where n is an even number, and one where n is an odd number. So we can calculate this S1 when n is equal to 2m, and in that case S1 would be equal to 0, and then there is another S1 where n, it can be expressed as 2m plus 1. In this case the S1 would be equal to 1. Okay, so that's one. So we're just following the same method that others have used to prove that this summation is equal to minus 1/12, and maybe we may be here refining their results. So if this is S1 for two different cases, it can be either 0 and 1. We are talking here the mathematician's language. For physics, we could very easily say that that's 1/2. And then we have this S2. This S2, in case S2 when n is equal to 2m, this one S2 would be equal to, how can we say, where do we have this one, is equal to minus m. That's what S2 would be equal to. And one way to prove this one is that this S2, we can write this one as S3 plus S4, where the S3, it can include adding 1 plus 3 plus 5 plus 7. So here we may have the summation of 2k plus 1, where k goes, or 2k minus 1, maybe better, where k goes from 1 to m. Okay, and just remember again, so the major thing here is that the m is kind of the half of n. And then here we have to do minus 2 times, then we have to subtract these negative numbers, okay? Minus 2, minus 4, minus 6, which would be equivalent to take the minus 2 parentheses, and then we're going to have 1 plus 2 plus 3. So here we are going to have this k, and k goes from 1 to m. So that's what we are going to have, okay? And as we have this situation here, if we do the calculations, we're going to have that when n is equal to 2m, that's what we get. S2 is equal to minus m. And S2, when n is going to be an odd number, when this is 2m plus 1, the result for S2 is going to be m plus 1. so this would be, so the uppercase would be where S1 and S2 when m is equal to 2m, and here we're going to have the result for the, sorry, this is, yeah, this is S1, this is S2. Okay, that's right. So this is S1, S2, S1, S2 for two different cases. The uppercase is when m is an even number, and the lowercase is when n is an odd number. Yeah, and once we have this result, actually we will not have much trouble. But the thing is that for these two different situations, if we once this S1 is given by this number and S2 is given by this, we're going to have that S when n is equal to 2m. So now we are going to write the results. This result, using the same way that the physicists use to prove that this leads to this result, we follow the same method as they did, but our numbers are a little different. And then we get to this value where s is equal to 2, when s, in this case, for an even number, we are going to have the following, 2m plus 1 times m, and the other one, s, when n is equal to 2m plus 1, that makes it an odd n, and this would be equal to 2m plus 1 times m plus 1. And yeah. Now, yeah, our results are different from what it was suggested before, which is -1/12. Of course, it's different, but still we have big trouble because this n is half of infinity if n goes to infinity. So it's not that we have solved the problem, but at least we say that you know what, those numbers out there, they are right only if we consider the probability, or if we use the same ideas that physicists used in the case of when they analyze a certain particle which can have a certain probability of being in one state and another probability of being in another state. And overall, yeah, they assign something which can be explained by probability curves. They say that, well, here we are, the probability of being somewhere here, that's what we have, but at a certain range of x, it's something else, and so on. So yeah, the question stands just for the fact that we don't understand what infinity is. And with regard to the physicist, physicists should be very careful when we talk about infinity, because we know that the speed of the speed limit for a highway, it may be 100 km per hour or 120 km per hour, but in everywhere, for sure, the speed limit is the speed of light, which we cannot pass that for sure. So yeah, you better write the speed limit everywhere you go. V is equal to c. And just for a second, if we make a question, if we ask questions like this, such as we know that hard drives, they move at a speed of approximately 7,200 revolution per minute. So that's how fast they can rotate, which makes it approximately slightly less than 1,000 radian per second. So with an omega which is 1,000 radian per second with this speed, the question is, can we have a hard drive with a radius of 4,000 kilometers? Yeah, can we have a hard drive which has a radius of 4,000 kilometers, which is something like 4 times 10 to the power 6 meter? Is it possible, for example, to have such a hard drive rotating with this speed, 1,000 radian per second, with such a radius? Now think for a moment, what would be the speed at one of the corners of the hard drive? We know that the speed is going to be equal to omega times the radius. So here we have 1,000 times 4 times 10 to the power 6 meter. And we are going to get something like 4 times 10 to the power 9 meter per second, which is more than the speed of light. So yeah, then what is going to happen? Now it may not be a hard drive, it can be something which rotates slower, but then the question would be still valid if this radius would be again larger. So physicists, yeah, we may talk about large numbers, but we know that everything is limited the universe has a limited size, because we know the time of the Big Bang, we multiply it by the maximum expansion speed of the universe, and then most probably we're going to get a finite number, okay? We won't get out of, because everything has a beginning. But again, the reason I talked about this example, it was mainly just to remind that physicists may be good, or the models that physics, or that are used in physics and in math, they may be very well approximated with this idea that this S1 can be 1/2, or the radius of an electron in a hydrogen atom. Yes, it can be over there somewhere at 1/2 angstrom, or 0.5 angstrom, but still, when we deal with problems which lead to infinity, let's not forget that physics does not like this quantity which goes to infinity. And yeah, now there are some other proofs that try to prove this result of S which goes to -1/12, which are done by pure mathematicians. Maybe we need to look also from their perspective to see what is going on. And yeah.